Hello, everyone. Welcome back to the final session in this MicroLED Connect event. And I think it's going to be a really interesting one. And the first company is Polar Light Technologies. We've got Ivan Martinovic, the COO. And Polar Light developed a unique technology to deposit micro-LEDs. They call it a pyramidical LED. Uses a bottom-up growth approach. So here's Ivan. You can start, explain your technology and your status, and you've got the floor.
Great. Thank you, Ron, so much. Hello, everyone. I'll go ahead right away. So, micro-LED is set to revolutionize the display industry and enable applications in augmented reality for a consumer market. But not so fast. First, we have some pretty huge hurdles to overcome. So, my name is Ivan Martinovic. I've been working with micro-LEDs since 2018 in everything from growth, characterization, and device design. And at Polar Light Technologies, we're a semiconductor startup developing the world's brightest, smallest, and most energy-efficient micro-LED technology. So this talk will focus a lot on micro-LEDs for projector applications in optical augmented reality. This means no VR, no pass-through AR, but the projector-based optical augmented reality. Okay, so why do we say that micro-LED can enable augmented reality applications? Well, we're really talking about the consumer application here, where the current headsets and current AR devices are something that not a lot of people want to wear. So that's the issue. And the issue with device form factor comes from compromises that are made when designing the light engine. So to fill the light budget, current technologies like OLED or LCD compromise on any of the three parameters that I'm showing here around the light budget triangle. So either the display is not inherently bright enough, like in OLED, for example, the size may be too large to fit into a sleek form factor, or it is not efficient enough, which then in turn requires big batteries, again, compromising the design. So we want to go from the big and bulky glasses, which are perfect, I would say, for professional applications, to a complete augmented reality experience in a good-looking pair of glasses for the consumer. So this is where micro-LED comes into play, and it is the only display technology that can fill the light budget in an uncompromised way. So conventional technologies like LCD or OLED do not meet the performance targets. LCD having reached its maturity and OLED not being projected to ever be able to deliver the brightness required in these optical AR systems. So micro-LED is promising then to outperform the incumbents on pretty much all KPIs, and only maturity and cost stand out as the biggest areas of improvement. So I'd argue there's still much to do considering performance, but I'll get to that in a bit. So as you know, the main driver for lowering cost in micro-LED, and then not only for micro-projectors, but micro-LED as a whole, is to decrease die size. We need to shrink it to micron or submicron size. So this comes with severe performance implications for most micro-LED approaches. And different micro-LED technologies might address a few of the performance targets, but really the combination of everything is needed for consumer AR. Particularly, I would say the combination of high efficiency at micron size. So I'd like to elaborate a bit more on that point.